The circular slide rule side of the E6B flight computer is a versatile tool capable of performing various calculations essential for aviation, as well as conversions between different measurement systems. We will not cover all its functionalities because ForeFlight offers a much more superior alternative. However, understanding some basic functions of the E6B remains crucial, especially for preparing for written test. In this video, we'll demonstrate how to compute distance, time, and speed using the E6B with this equation. These calculations are essential for dead reckoning, a vital technique in cross-country navigation. E6B has 3 circular scales. This outermost fixed ring is the A scale. The middle B scale and the inner C scales are mounted on a rotatable disc, allowing you to line up their numbers with those on the A scale. The B and C scales are synchronized to facilitate time conversion. For instance, if the B scale represents time in minutes, the C scale denotes time in hours. Thus, 90 minutes on the B scale corresponds to 1 hour and 30 minutes on the C scale. Similarly, if the B scale represents time in seconds, the C scale indicates time in minutes, so 90 seconds equates to 1 minute and 30 seconds. Be aware that all 3 scales have floating decimals. This means a number, say 10, can stand for different decimal values, like 1, 10, 100, 0.1, and so on. This feature is handy but can get confusing, so stay alert when doing your calculations. C scale is not often used due to its synchronization with B scale. Most computations predominantly rely on the A and B scales. In our calculation, we will use A scale to represent distance in nautical miles and the speed in knots. If you prefer statute miles, then the speed will be miles per hour. Just be consistent. We want B scale to denote time in minutes. This can be done by choosing this black triangle on B scale as our speed index. See the number 60 beneath the triangle? It indicates 60 minutes, which equals 1 hour. This is not the only speed index, but when it is in use, the numerical values of B scale read time in minutes. If necessary, you can always check the C scale for time in hours, but for simplicity, we'll stick to only A and B scales. Let's see why it's called the speed index. Speed is essentially how far you travel in a given amount of time, like miles per hour. Mathematically, it is distance divided by time. Because the numerical value of our speed index is 60, representing 60 minutes. We substitute 1 hour in the equation with 60 minutes. Check the equation on the E6B, you'll notice it is literally the definition of speed. Suppose the speed is 100 knots, meaning the airplane travels 100 nautical miles every 60 minutes. Align the speed index with the number 10 on A scale, as it represents 100 in this case due to the floating decimal. Now you have the left-hand side of the equation set. Based on the speed you just set, each pair of numbers on A and B scales tells you how far you can go in a certain time. For instance, 150 nautical miles takes 90 minutes, and 300 miles requires 180 minutes. What's really cool about the floating decimal is that it works with any decimal place. So, that 90? If you consider it as 90 nautical miles, the time it takes is 54 minutes. Scaling up to 900 miles, the required time becomes 540 minutes. You see, once you have set the left-hand side of the equation, the right-hand side automatically aligns. This should not come as a surprise, as both sides of the equation must be equal. Give it a try and check for yourself. When solving distance or time problems using the E6B, we begin by setting up the side of the equation that contains no unknowns. For instance, if we are seeking the distance, we cannot initially set the E6B using the right-hand side because distance is what we are looking for. Eventually, since the speed index is predetermined, whenever a speed is known, we start with the left-hand side. Let's align the speed index with 12. Given that the time is provided in hours, we need to first convert it to minutes. Next, read the distance from the A scale where it is directly aligned with the time value of 99 on the B scale. To figure out the speed when you know the distance and time, Begin with the right-hand side of the equation. Line up the time with the distance. The speed is the number pointed to by the triangle. Simple as pie, right? A friendly reminder. When calculating dead reckoning related info, you're using ground speed, not airspeed. Need a refresher on how to find ground speed? Check out the video on the E6B wind side. The link is in the description below. Sometimes, a leg of a cross-country flight might be as short as just a few miles. You can still use the same speed index to find out that flying 5 nautical miles takes about 2.73 minutes. But let's be honest, do you really want to deal with decimals while flying? In such cases, measuring time in seconds might make a bit more sense. We can do this by selecting a different speed index. Notice the small arrow labeled seconds on the B scale next to the number 36? It corresponds to 3,600 seconds. By using this index instead of the standard 60, the numbers on the B scale indicate time in seconds. Aligning this new index with the speed on the A scale, we got the time needed to fly 5 nautical miles is 164 seconds. That is 2.73 minutes.